Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2011. So let's get started. First problem, what is 2 plus 4 plus 6 over 1 plus 3 plus 5 minus 1 plus 3 plus 5 over 2 plus 4 plus 6? This is 12 over 9 minus 9 over 12. This is 4 over 3 minus 3 over 4. This is 16 minus 9 over 12. This is 7 over 12. So the answer is C. Number 2, Josanna's test scores to date are 90, 80, 70, 60, and 85. Her goal is to raise her test average at least 3 points with her next test. What is the minimum test score she would need to accomplish this goal? Okay, so her total scores right now are, this is 150, so it's 385 divided by 5. This is 77, and so her score is 77 right now. Raise her test average at least 3 points. This means that this should become 80. So the average has to be 80, and so this is 90 is 80 plus 10. 80 is average. 80 is the same thing. 70 is average minus 10. 60 is minus 20. And 85 is plus 5, and so these two cancel, and so for this to make it a 0, then we need a plus 15. So 80 plus 15, what that gives us is 95. The answer is E. Number 3, at a store when length is reported as x inches, that means the length is at least x minus 0.5 inches and at most x plus 0.5 inches. Suppose the dimensions of a rectangular tile are reported as 2 inches by 3 inches. In square inches, what is the minimum area for the rectangle? So it's a minimum, so we will have to suppose that this is the smallest. So this is 1.5 inches by 2.5 inches. So 1.5 is 3 over 2. This times 2 over 5 is 5 over 2. This is 15 over 4. This is 3.75. The answer is A. Number 4. Leroy and Bernardo went on a week-long trip together and agreed to share the costs equally. Over the week, each of them paid for various joint expenses such as gasoline and car rental. At the end of the trip, it turned out that Leroy had paid $A and Bernardo had paid $B, where A is less than B. How many dollars must Leroy give to Bernardo so that they share the costs equally? Okay, so Leroy paid $8, Bernardo paid $B, and so and since A is less than B, so the difference would be B minus A, and so to make the difference 0, Leroy would have to give this divided by 2 to Bernardo, and so the answer is B minus A over 2. The answer is C. Number 5, in multiplying two positive integers A and B, reverse the digits of the two-digit number A. His erroneous product was 161. What's the correct value of the product of A and B? So 161, we could divide this by 8. No, 3 doesn't work. And let's try 7. 7, then this becomes 2, 14, 3, 21. So A is 23 and B is 7. No. So the digits that were reversed, this is 23. And so A itself will be 32. And so the correct value of the product is 32 times 7. This is 14, 32, 21, 22, 24. The answer is E. Number 6, on Halloween, Casper ate 1/3 of his candies and then gave 2 candies to his brother. The next day, he ate 1/3 of his remaining candies and gave 4 candies to his sister. On the third day, he ate his final 8 candies. How many candies did Casper have at the beginning? Okay, so last he had 8 candies. Before he gave them, he had 12 candies. And before he ate 1/3 of them, he had 18 candies. Before he gave 2 candies, he had 20 candies. That was 2/3 of his total candies, so this was 30. And if we go back, it all matches up. When 1/3 is eaten from 30, we have 20 left. When 2 is given, we have 18 left. And when we eat 1/3 of this, we have 12 left. If we give 4, we have 8. So the answer is 30. The answer is A. Number 7, the sum of two angles of a triangle is 6 over 5 of a right angle. This means it's 6 over 5 times 90 degrees. This is 6 times 18. This is 48, 108 degrees. And so the remaining angle is 72 degrees. And one of these two angles is 30 degrees larger than the other, and their sum has to be 108. So 108 minus 30 equals 78, and 78 divided by 2. this would be 39 and 39, and since one is 30 degrees larger, this will be 69. So one will be 39, one will be 69, and one will be 72. What's the degree measure of the largest angle? It's this. The answer is 72. It's B. Number 8, at a certain beach, if it is at least 80 degrees Fahrenheit and sunny, then the beach will be crowded. On June 10, the beach was not crowded. What can be concluded about the weather conditions on June 10? Okay, so the beach will only be crowded if it's at least 80 degrees Fahrenheit and it's sunny. So they have to be both 80 degrees Fahrenheit and sunny for the beach to be crowded. And since the beach was not crowded, so it could either have been not sunny. So it could either have been not sunny, or less or cooler than 80 degrees Fahrenheit, right? And so it's this or this. So the answer is B. Number 9, the area of EBD is 1/3 of the area of 3, 4, 5 triangle ABC. Segment D is perpendicular to segment AB. What is BD? Okay, so the total area here is 3 times 4 divided by 2. That's 6, and it's 1/3 of the area. So this much would be 2. So the area will be 2. And if this is and since this triangle and this triangle are similar, let's see that this is 3a and this is 4a, and so 6a squared would be equal to 1. No, 6a squared would be equal to 2, right? A squared equals 1 over 3, a equals 1 over root 3, and so BD equals 4a equals 4 over root 3. This is 4 root 3 over 3, 4 root 3 over 3. So the answer is D. Problem number 10. Consider the set of numbers 1, 10, 10 squared, 10 to the 3rd power, all the way to 10 to the 10th power. The ratio of the largest element of the set, so that would be this, to the sum of the other 10 elements is closest to which integer? Okay, so this will be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and these and the rest together would have been 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right? But then note that this, the top one, this is extremely similar to 999999999, right? Because this plus 1 is what gives us this, and so it's very similar. And then this would still be the same 1 1 1 1 1 1 1 1 1, and then this would be 9, right? And we should say this is extremely similar, and so this is very similar to 9. The answer is B. Number 11, there are 52 people in a room. What is the largest value of n such that the statement at least n people in this room have birthdays falling in the same month is always true? Okay, so let's think that there are as least as can be. So so the first 12 people are all in different months. The next 12 people are also all in different months. Then how we can get this is 52 divided by 12, right? Since there are 12 months, and then we get 4 and 48, right? And then we have 4 left over, and so those 4 would have to have a month in one of the 12 months, right? So their birthday would be in one of the 12 months, so they would be 5, right? So it's plus 1, so 4 plus 1 equals 5, and so the largest value of n such that at least n people in this room have birthdays falling in the same month, that would be 5. The answer is D. Number 12, Keiko walks once around the track exactly the same constant speed every day. The sides of the track are straight and the ends are semicircles. The track has a width of 6 meters and it takes her 36 seconds longer to walk around the outside edge of the track than around the inside edge. What is Keiko's speed in meters per second? Let's try to draw this if we can. Let's say that the radius of this much is A, and this would be 6, it said. This is also A, 6. And it said that it takes her 36 seconds longer, right? And so, since the time walking on the straight paths would be the same, then the difference would come from these, right? And so that the difference would come from the difference in circumference of the two of the two circles, right? Because when they're together, they become circle. So 36 seconds. This is 2a plus 12 pi minus a minus 2a pi, right? This is 12 pi, and so 1 second would be 12 pi over 36. This is pi over 3. The answer is A. Number 13, two real numbers are selected independently at random from the interval minus 20, 10. What is the probability that the product of those numbers is greater than 0? Okay, so two real numbers are selected independently. So there are 30. So since two are selected, it's 30 squared. And then what is the probability that the product of those numbers is greater than 0? Okay, so then this should be plus plus or minus minus, right? And so plus plus, this should be 10 and 10, and this should be 20 and 20, right? Since it's minus 20 to 0. And so this would be 10 squared plus 20 squared. This would be 3 squared under 1 squared plus 2 squared. This is 9 under 5, so this is 5 over 9. The answer is D. Number 14, a rectangular parking lot has a diagonal of 25 meters and an area of 168 square meters. In meters, what is the perimeter of the parking lot? Okay, so if we see that a diagonal is 25 meters, then two things must spring to mind. It's the 5 for 3 triangle, so it will be 25, 20, and 15, or it could be like this. So it could be a 25, 24, and 7 triangle. They are both right triangles. Let's try this one first. 20 times 15, this would be 300, but the area is not 300, it's 168. So this is crossed out. Let's try this. 24 times 7, this is a 4 by the way. 24 times 7, this is 168, so this is perfectly, yeah, so that's perfect. So this is the parking lot, and in meters worth is the perimeter of the parking lot, so it's 7 plus 24 plus 7 plus 24 equals 31 times 2. This is 62. The answer is C. Number 15, let alpha, no, this is not alpha. Let at denote the averaged with operation A at B equals A plus B over 2. Which of the following distributive laws hold for all numbers x, y, and z? And so for I, let's say that, so this one, this is x plus y plus z, no, this is y plus z over 2, x plus this over 2, this is 4 over 2x plus y plus z, right? But then this would be but then that would be 2x plus y plus z over 2, right? And so this is 4, this is 2, these are not the same, so I is wrong, these are wrong. And so and the number 2, x plus y at z, so let's erase these. This will be x plus y at z is x plus y plus z over 2. This is 2x plus y plus z over 2. And then x plus y at x plus z, this is x plus y plus x plus z over 2. And then this is the same as this, right? And so these and these are the same, so this is right, so 2 is right, and so these two are right, so it's one of B and E, it's not C. Third problem, so third one, x at y at z equals x at y at x at z. This is so the first one would be y plus z over 2, and then x plus that, this over 2, this would be 4 over 2x plus y plus 2, and then this would be x plus y over 2 plus x plus y, no, plus x plus z over 2 over 2, but then this would be 2x. This would be 4, and then 2x plus y plus z. Yeah, and so this is right. So these two are the same. So 3 is also right. So the answer is 2 and 3 only. It's E. Number 16, a dartboard is a regular octagon divided into regions as shown. Suppose that a dart thrown at the board is equally likely to land anywhere on the board. What is the probability that the dart lands anywhere within the center square? Okay, so let's say that this length is 1, right? If this length is 1, this is 1, 1, 1, 1, 1, 1, 1, 1, and then since this is a 90 degrees and 45 degrees, this will be root 2, and since it's a regular octagon, this is also root 2, so this would be root 2, and this would also be root 2, and so the center would be root 2 squared is 2, and whole would be, this is 2, plus this is 1, 1, so plus 2 plus, and then this is root 2 times 4, right? 4 root 2, this is 4 plus 4 root 2, and so the dart lands in the center square. This is 2 over 4 plus 4 root 2. This is 1 over 2 root 2 plus 2. This is 2 root 2 minus 2 over 4. No, over, yes, so it's over 4. This is, divide this by 2. Root 2 minus 1 over 2. The answer is A. Number 17, in the given circle, the diameter EB is parallel to DC and AB is parallel to ED. The angles AEB and ABE are in the ratio 4 to 5. Okay, and since this is a 90 degrees, these two, the sum would be not 90 degrees, so this would be 40 degrees, and this would be, so this is 40 degrees, and this would be 50 degrees. What is the degree measure of angle BCD? This angle right here. So first let's draw a few lines. Let's connect like that. Wait, no. Let's connect like this and connect like that. Okay, so since we know that these two are parallel, then we can we can say that this angle is the same as this angle, right? Since they're both 90 degrees. And since this is not 90 degrees, this would be 50 degrees, right? Since this is 40 degrees. And since this is 50 degrees and this is an isosceles triangle, this would also be 50 degrees. And so this would be 80 degrees, right? And then since this line and this line is parallel, and this line is intersecting both of them, we can see that this angle would also be 80 degrees, right? Let's put it here, 80 degrees. But then this triangle is also an isosceles triangle, so let's say that this is F, so FDC, that's this angle, that's 80 degrees, and so FCD would also be 80 degrees, right? And also since this is 80 degrees, same thing with these two lines and this line here this time, so this angle and this angle is the same, and so what we can get is this is also 80 degrees, and since it's the same isosceles triangle, this would be 50 degrees, and so FCB would be 50 degrees. What's the degree measure of angle BCD? So it's this whole thing, so it's this total, so BCD would be FCD plus FCB. This would be 80 plus 50 equals 130. So the answer is C. Number 18, rectangle ABCD has AB is 6 and BC equals 3. Point M is chosen on side AB so that AMD equals CMD. What is the degree measure of AMD? So this angle and this angle would be the same. What is the degree measure of AMD? So since this is M, we want this degree measure, and since this and since these angles are the same, let's say that this is circle, then this is also circle, right? But since these two are parallel and this is intersecting, then that would mean that this is also circle, right? And so since this is an isosceles triangle and this is 6 and this is 3, since this is isosceles, this is 6 and this is also 3, right? Because it's just the side. And so we have a 6 to 3, so this is 2 to 1, and then we have 90 degrees. that means that this is a 30, 60, 90 triangle. So this would be 30 degrees, this would be 90 degrees. And since the whole thing is 180 degrees, it's 180 minus 30 over 2. This is 75 degrees. So the answer is E. Okay, so problem 19. What is the product of all of the roots of the equation root 5x, 5 absolute value of x plus 8 equals root x squared minus 16? So if so x can be positive or negative, and if if x is positive, then this would be 5x plus 8 equals x squared minus 16, and if it's minus, then it's minus 5x plus 8 equals x squared minus 16, right? So let's go with both cases. X squared minus 5x, so that first, minus 5x plus, no, x squared minus 5x minus 24 equals 0. Then this will get 8 and 3, right? So this would become x equals 8 or minus 3. And for this one, it will be x squared minus plus 5x minus 24 equals 0. So this will be 8 minus 3. So this will be x equals minus 8 and 3. But since this is when x is negative, then it will be minus 8. Since this is when x is positive, then this will be x is 8. So 8 times negative 8 equals minus 64. The answer is A. Problem number 20. Rhombus ABCD has side length 2 and the angle of B is 120 degrees. Region R consists of all points inside the rhombus that are closer to vertex B than any of the other 3 vertices. What is the area of R? So first let's draw this rhombus. A, B, C, D, since it did say that B is 120 degrees. D. And so this is 120 degrees, and so this would be 60, this would be 60. If you cut this in half, this would be 60 and 60. Region R consists of all points inside the rhombus that are closer to vertex B, right? And so what we want is the center of each of these triangles, and then straight line, straight line, straight line. And so what we want is this area, right? And then this area will be 1/3 of the total thing, right? Of the total thing, and since the side length is 2, of the total thing is 2 times root 3 over 4 times 2 squared. This is, these cancel, this is 2 root 3 over 3. The answer is C. Number 21. Brian writes down 4 integers. W is greater than x, is greater than y, is greater than z. Sum is 44. The pairwise positive differences of these numbers are 1, 3, 4, 5, 6, and 9. What is the sum of the possible values of w? Okay, so let's just say that the first term is a, and the first term should be like and the first term is the lowest term, and so it's a something something, and then since the greatest difference is 9, then it must be the difference between the first and the last numbers. So the last number should be 8 plus 9. And then we have 2 ways of getting what's inside here. First, we could have either these 2 or these 2, right? So it's a plus 3 and a plus 4, or a plus 5 and a plus 6. And of course, right here would be a and a plus 9, all the same. And so if you see right here, this is 3, this is 1, this is 4, and this is 5, this is 6, and the whole thing is 9. That's how it adds up in this one. So it would add up like that, and in this one, no, and in this one, it would be a plus 5. This is 5 first, and then this is 1, and then this is 6. This would be 3. This would be 4. That would be 4, and the whole thing would be 9. So that's how it would be in the second point. And so if it's like this, then the sum is 44, right? So if we add these all up, 4a plus 16 equals 44. So a equals 28 no, 4a equals 28, a equals 7, and here 4a plus 20 equals 44, and so 4a equals 24, a equals 6. What is the sum of the possible values for w? And this is w since, and a plus 9 is w since it's the biggest number, and so w would be 7 plus 9, which is 16. W will be 6 plus 9, which is 15. What's the sum of the possible values for w? This would be 15 plus 16. The answer is B. Number 22, a pyramid has a square base with sides of length 1 and has lateral faces that are equilateral triangles. A cube is placed within the pyramid so that one face is on the base of the pyramid and its opposite face has all its edges on the lateral faces of the pyramid. What is the volume of this cube? Okay, so let's just draw the pyramid first. So this would be the cube. I know it's not that great, but let's just say that this is the cube. The sides are length 1, so this is length 1, 1, 1. And there are equilateral triangles, and so if this is, and so since that's the center, it will be like, if we have like a horizontal length like that, if we have a length like that, then this would be the height, right? This would be the height, and then if we put in a length like that, that would make us, yeah, since this is 1 and 1, the whole thing would be root 2, but then this is half of the whole thing, right? So this would be root 2 over 2, and so this would be 1. So 1 is 2 over root 2, so this would also be root 2 over 2, right? But then let's look at this kind of half cut face, yeah? So that would be like this. It would be a 45, 45, 90 triangle, and this would, and the whole thing would be root 2 over 2, and then there would be the part of the square like that, and then if and then let's say that the sides of the cube is 2a, so this will be 2a, then that will make this root 2a, right? Since this is 2a and this is 2a and this is half of the root 2 of the whole thing, so this would just be root 2a, and so since this is 45, 45, 90, this would be root 2a, this is 2a, so 2a plus 2 root 2, no, 2a plus root 2a equals root 2 over 2, and so a equals 1 over root 2 times 2 plus root 2 over 1. So the answer is 2 root 2 plus 2 over 1. And if we make this, and if we make this like and if we change this up, we could multiply 2 root 2 minus 2 right here, and that would make over 4. 2 root 2 minus 2 over 4. This is root 2 minus 1 over 2, and so a would be 2 root, so a would be root 2 minus 1 over 2, and so 2a would be this times 2, so these 2 would cancel, so 2a equals root 2 minus 1, and so the volume is root 2 minus 1 cubed. This is 5 root 2 minus 7. The answer is A. Number 23, what is the hundredth digit of 2011 to the 2011th power? Okay, so this one, we can easily see that this, see that the hundredth digit of this is the same as the hundredth digit of 11 to the 2011th power, because this whole thing is 2000 plus 11, this whole thing to the 2011th power, and it's no good. That's because this is over 1000. Yeah. So it's because this has a 0 in the hundredths place, so that's why it's kind of useless. And so it's the same thing as 11 to the 2011th power. And this is also same as 10 plus 1 to the 2011th power, right? And so we are going to use the binomial theorem. And so 10 plus 1 to the 2011th power would be the same as 2011 choose 1 times 1 to the 2011th power times 10 to the 0th power plus 2011, no, first is 2011 C0, right? C0. And then the next is 2011 choose 1 times 10 to the 2000 times 1 to the 2010th power times 10 to the first power plus 2011 choose 2 times 10 to the times 1 to the 2009th power multiplied by 10 to the second power plus 2011 choose 3 times 10 to the 2000 times 1 to the 2008th power, and then times 10 to the third power. Okay, but from here onwards, everything is meaningless because we are solving for the hundredths digit, and this gives us and the first non-zero digit that this gives us is on the thousandths power. So that's of the thousandths, right? So we don't need until this. So all we care about is this thing, and the hundredths digit of this will give us the hundredths digit of this. And if you see, this is just 1 times this is also 1, this is also 1, so this is 1 plus, and then this is 2011 times this is 1, and this is 10, so this is 20110, and then this would be 2011 times 2010 over 2, and then multiply, and then this is just 1, so it's gone. This is multiplied by 100, and so this is not and so this doesn't pertain to the hundredth place, so this can be just erased. And so this is 20110 plus, and then this is 2011 times 1005, this times 100, and we don't need to solve for this whole thing, because all we're looking for is the units digit of this number, because this number will be multiplied by 100, and so the units digit of this number will be the hundredths digit of this whole number, right? So this hundredths digit is 1, this hundredths digit is 5 times 100, so it's 5. So 1 plus 5 equals 6. The answer is 60. Answer is D. Number 24. A lattice point in an xy coordinate system is any point to x, y where both x and y are integers. The graph of y equals mx plus 2 passes through no lattice point with x is greater than 0 and less or equal to 100 where all m such that m is greater than half but it's less than a. What is the maximum possible value of a? Okay, so what we need for m is, so each fraction is a fraction. So we need the least fraction, right? So we need the smallest multiple of 1 over n that exceeds 1/2, right? And so if n is 3, then it will be 2 over 3 because it's the smallest multiple of 1 over 3 that exceeds 1/2. And then and then if n is 4, then it will be 3 over 4 because it can't be 2 over 4 since it has to exceed 1/2. And so if we keep going, this will be 3 over 5, 4 over 6, 4 over 7, 5 over 8, 5 over 9, and then on we go. And then we'll reach something 98. If n is 98, then this will be 39 plus 1, so it will be 49 plus 1, so it will be 50, and then it will be 99, and then it will be 50 over 99, and then it will be 100 under 51, and then it will stop there because because the greatest value of x can be 100. So this is where we stop. And so from here we're looking for the least value, right? Because if we don't get the least value, then there will be a smaller value, so it will pass through that lattice point, right? So for example, if we choose 4 over 7, then since 5 over 9 is less than 4 over 7, we could say that this would pass through 9 comma 5 before so we can see that could pass through 9 comma 5 when the coordinate is when the slope is 4 over 7, right? So that's why we would have to try to get the least value, and we can see that the least value is 50 over 99 because it's like obviously either this or this, right? But then if you cross multiply, then this becomes 5,099 times 51, which is 99, 51, 99, 45, 45, 5,000, 49149. So 5,049. So this is smaller, so this is smaller. 50 over 99 is the least value, so the answer is 50 over 99, which is B. Last problem, problem number 25. Let T1 be a triangle with sides 2011, 2012, and 2013. For n is greater than 1, if Tn is triangle ABC and DEF are the points of tangency to the end circle of ABC to the sides AB, BC, and AC respectively, then Tn plus 1 is a triangle with sides length AD, BE, and CF if it exists. What is the perimeter of the last triangle in the sequence Tn? Okay, so let's try to make a triangle, and 2011, this would be 2011, this would be 2012, this would be 2013. For n is greater or equal to 1, if Tn equals ABC, right? So if this is ABC, DEF are the points of tangency to the end circle of ABC. So let's make the end circle, and that would be tangent like that. These sides AB, BC, and AC respectively. So if we plot these points and connect them, Tn plus 1 will be the triangle with the side length AD, BE, and CF. So what we want is, this is 2011, 2000 further back, this is 2012, and this is 2013. And what we want is, this would be DEF is AB, BE, and AB, BC, and AC, right? So this is D, this is E, this is F, and so let's try to find what the values would be for each of these lines. We all know that this and this is the same value. This and this is the same, and this and this is the same, right? So first we can see that so we would be dividing it pretty evenly, right? So this would be just 2012 divided by 2. This would be 1006. So this would be 1005 to make it like that. 1005, and then since this would be 1005, this would be 1006, this would be 1007, and so this would be 1007, and it all makes sense. So the next triangle would be a triangle with the side length 1005, 1006, and 1007. So let's just try and order the side lengths. So the first one is 2011. The first is 2011, 2012, 2013, and the next one is 1005, 1006, 1007. And then if you try the next one, it will get 503 and 502, 504. Okay, so we notice a pattern that, and it's that the middle number, it's always dividing by 2, and these two numbers on either side of it, they are always one less and one more than the previous number, right? So this is half, and this is one less, one more. Same thing for this one. This is half, this is one less, one more, and so and so um and so we would go on to the point that this is 503 over a, where a is where a is 2 to the nth power, and this would be 503 minus a over a, and this would be 503 plus a over a, right? And so if we erase this, then yeah, then the first time that the triangle does not exist, this would be when these to the sum is actually less than or equal to this, right? So 503 minus a over a plus 503 over a is less than or equal to 503 plus a over a. So these could be erased, and so these would cross out. 503 is less than or equal to 2a, so a will be greater than or equal to 251.5, and since a has to be 2 to the nth power, then this would be a, then the least value of a could be 256. And so the first triangle that does not exist would be when a is 256. So the last triangle that does exist is when a equals 256 divided by 2, which is 128. And so that's when it's 503 over 128, and 503 plus 128 over 128, and then 503 minus 128 over 128. And so if we add these together, then it's 3 times 503 over 128. This is 1509 over 128. So the answer is D. And that was the problem number 25 of the 2011 AMC 10B, and thank you for watching.